All right, so here we go. Thursday afternoon, Thursday evening, when you're doing this. I don't know about you guys, but I'm ready for those Marvel shows to be on Disney Plus, right? So, Falcon and the Winter Soldier, right? WandaVision, Loki, all right. So I'm ready for something that to come back in. I'm wearing my Guardian shirt, right? So Guardians of the Galaxy. Ooh, oh, wrong way. Turn on the camera. There we go. All right, I know they're working on that soon. Eventually, get that going. I need Guardians 3. So, looking forward to some things. What are you looking forward to besides doing great math right now? There's got to be something else that you're looking forward to, just the same way I'm looking forward to. So, hopefully, we can rock through this, and then you can get to some of those things that you're looking forward to as we go. Now, once again, we're on Unit 2, Lesson 7, Graphing and Writing Equations of Absolute Value Functions. So these are the notes you have in front of you. And very much like what we've done the last few lessons, we're going to have you doing an exploration in Desmos, all right, to see some patterns, right? And once again, hopefully you'll translate what we've talked about with lines into some things with absolute value. So I do want to show you one thing before you pause the video in Desmos. All right, so I'm going to pull Desmos up here. If you need to pause the video so you can pull Desmos up, that would be great. I want to show you this. Just might make your life a little bit easier because notice that we're going to do absolute value and then we're going to do quadratics in the next lesson. So I want to show you some functionality things here in Desmos. So, all right, so when you go here, we've been typing in equations, right? But I also wanted you to make you aware of this keypad at the bottom left here. So notice when it says show keypad, right? If I click on that, now I get all these different things here that I can use if I would like. So you can see there's our absolute value bars. Here's how we'll do quadratics with our square right here, right? So you can have your division. So you have a lot of these different types of things. So if I wanted to type y equals the absolute value of x, which is this first guy here, it would be y equals, and then I can just go down here and hit this, and it puts those absolute value bars in for me. And I can just type my x in like that. All right, and then I can just click out here, and it automatically closes those bars for me, just like that. So there's my graph of y equals absolute value of x. All right, so I wanted you to see that functionality in case you had any issues. You can also use the bars on the keypad and type those in if you would like as well. So, all right, let me click this out of the way here. So here's what I would like you to do. All right, so go through. All right, so you have this page. All right, 1, 2, and 3. All right. You have 4, 5, and 6 on the back. All right, so once again, all right, graph this, take this, put it in Infinite Campus. That's not what I want you to do. I want you to put it in Desmos. Infinite Campus will not help you. All right, don't know why that came out of my mind. So graph this, answer your questions, and once again, I think it's just great for you to sketch a quick graph on this. That way, if you're going back through your notes and you're studying, you're looking at things, you have those there in front of you. So go ahead, pause the video. All right, go through this exploration. It shouldn't take you too terribly long. Flip that video back on, and we'll see how you did. All right, so I did the exploration as well. All right, and so here is what I have. All right, so the vertex or the turning point. So when you graphed y equals absolute value of x, we can see that that turning point is 0, 0. What's the slope of our increasing line? Hopefully you have 1 over 1. What's the slope of the decreasing line, which is the left half here? Let me move that cursor out of the way there. All right, is negative 1 over 1. All right, now if I go to number 2 here, here's our graph here. We can see that my turning point, my vertex is at 1, 4. All right, the slope here is 1. All right, the slope on the left side is negative 1 over 1. All right, and if we come down here, all right, to number 3, we can see that, all right, our turning point is negative 2, negative 3. The slope now, this time, the rising side, the increasing side is on the left, and it's 1 over 1, and the decreasing side is negative 1 over 1. All right, so hopefully you found all that through your exploration. Now, what I want to do is tie this in because some of the things that we've already talked about are going to be in common here. So let's go back to our lines here. And I just wrote 4 equations here. You don't have to write this down. I just want you to kind of watch and see how we translate some things that we should already know. So one is, we've already talked about how to find a point in an equation. So notice when I look at this equation, hopefully you know the point on that line is 2, 4. When you look at this equation, hopefully you know the point on that line is negative 1, negative 3. When you look at this equation, hopefully by now you're seeing that that point is 5, 0. And when you look at this equation, hopefully you see that that point is 0, 5. Now, what we talked about on the line is that this could be any point on the line, right? So we might not see 2, 4 if we're writing the equation. Somebody else might pick a different point, right? But we know when we see this, this is 2, 4. Now, here's what I want you to translate. Notice here, my vertex is 0, 0. Notice there's nothing inside my bars. There's nothing on the outside. Here, my vertex is 1, 4. I see that 1, 4 in the same way, right? I see my numbers down here like the 2, 4 right here, correct? And then once again, I see my vertex is negative 2, negative 3. I can see that negative 2, negative 3 in the same way I see negative 1, negative 3 in this equation. So we can see that point in the equation of an absolute value in the same way we can see the point in the equation of a line. Here's the difference. In a line, this can be any point that we see. But in absolute value, it's one specific point. And I know you're thinking it. It's that vertex, right? So the one point we see in the equation is that vertex. That's a big thing. So if we recognize that, we know just by looking at an equation what that vertex or turning point is going to be. Now, the next thing I'm going to translate for you, help you kind of pull from other pieces of information. We know that my rate of change, my slope for this line is 4. We know that my slope is 4, right? We know that that number in front is telling us our slope, correct? All right, so now let's go back to this guy. So we see that I have a slope of 1 over 1 and negative 1 over 1. And notice what's in front here, we have a 1. So we get plus or minus 1. And now because it's a positive 1, it opens up. Same thing here, 1 and negative 1. Look in front of our absolute value bar. We have a 1 here. Opens up. Now notice here, here's the difference. Now it's negative 1 in front. So we still have that plus or minus 1, which we've seen from our table of values, but because it's a negative here, it opens down instead of up. All right, so making some connections. All right, so let's flip to the back and see how you did. So once again, when I graph 3 times the absolute value of x plus 1, our vertex is 0, 1, right there, correct? And now once again, we can see that 0, 1. We can see that in the equation. What's our rate of change? Up 3 over 1, down 3 over 1. Can we see that rate of change out in front of that equation right there? There it is, right? And it's a positive 3, so that means we want it to open up, right? So I can see I go up 3 to the right one, up 3 to the left one. Let's look at number 5. All right, when I look at this guy, right, I see 1, negative 3 right here, just like we did for our lines. What's our vertex? 1, negative 3. All right, the slope of this is 1 over 2. The slope of this is negative 1 over 2. And notice we see that rate of change in front. All right, and finally, problem 6 here. Negative 3, 0 is our vertex, right? There we see it. We wrote it right there, and we can see that same pattern, negative 3. It's opposite here. There's really a plus 0 out here that we just don't see. We can see that my slope here is down 2 over 3, so that's that negative 2 over 3, up 2 over 3 there. So that's the exploration. So that's really the big thing that we want you to see, is that a lot of that same information that we were pulling and using from our equation of our line is very, very similar to what we see in an absolute value equation. So we can get that vertex from the equation. We can see the rate of change from the equation. And then we just have to pay attention to whether this rate of change is positive or negative. If it's negative, our V will open down. If it's positive, it will open up. So there we are, my friends. So quick exploration of absolute values. We'll come back into class tomorrow. It's Friday already, right? Well, Thursday now, I guess, but tomorrow is Friday. We'll do some more graphing and writing equations of absolute value and graph. You guys have a wonderful Thursday night. All right, see you tomorrow.